Okay, and so this problem, f of x equals mx plus b, where m is defined to be non-negative. Our limit L is m divided by 2 plus b. Our c is 1/2, and the value for epsilon is k greater than 0. Okay, and so this is just like the problem that we did yesterday in class. Okay, and so here we have the absolute value of f of x minus L is less than epsilon, and substituting in we have the absolute value of mx plus b minus our limit L, which is m divided by 2 plus b, is less than epsilon, which is k. Now we're going to simplify and use the property of absolute value to sandwich the inside between negative k and k. So here we have mx plus b minus m divided by 2 minus b. Okay, we notice here that our b's subtract out. All right, and so the quantity that we're left with in the middle, remember we want that to be x, so we're going to add the m over 2 to both sides. So what I end up with is negative k plus m over 2 is less than mx, which is less than k, plus m over 2. And then to get x in the middle, I'm just going to divide by m, so that's just multiplying by 1 all over m. So here, if we multiply each by 1 all over m, okay, and I'm running out of room here, but I'll just come up here. So I have negative k all over m plus m all over 2m is just 1 all over 2 is less than x, and then we have the positive counterpart, so k all over m plus 1/2. So that's our interval, negative k all over m plus 1/2, comma, and then the positive over here. Okay, and then that implies that our delta then would just be k all over m. And the reason for that is looking at the number line. Let's get that here. We have 1/2 is our value for c, and then if we are negative k all over m minus over here, and then over here positive, then it follows that each of these endpoints are k all over m units away, and so that's where our delta comes from.